I have to kill Klaus before he steals Francine. There's no time to lose.
That'll be $3.
What? That's a total rip. I'll park it myself.
Hi everyone, welcome to our project. We are Group 18, Smart Parking via Distributed Visions. The project is proposed to generate a more comprehensive and efficient solutions for the general parking in crowded cities. As the urban population grows and the number of vehicles increase, daily parking has become a significant issue for people who live in a high population density area. Therefore, our project has to help to maximize the efficiency of the parking in cities.
This project, I was responsible for the hardware design and the overall system design. For the hardware part, I'm using Raspberry Pi as my gateway device and connect with multiple sensors, including the lidar light sensor to detect distance, which perform a operation to detect if the next available parking space. And also, I implement a servo motor to perform a rotation function for the whole system to detect a dedicated area in the parking lot. 这样形容。
This project, I was working on the software development. So first of all, I was working on the setuping the Raspberry Pi, and working on the OpenCV on the Python on Raspberry Pi. So next, I was working on the license plate recognitions algorithm, so that we can generate all the result to the JSON file, so that we can use the JSON file to send back to the AWS server.
Project, I contributed mostly in the design of the whole project, and then I'm in charge of the database of the project, that I set up the DynamoDB table on the AWS, and then this table is used to store all the location information and the vehicle license plate information. I also established the IoT connection of the hardware to link it to the server, and so all the data can be uploaded to the server. And I do two Lambda functions for the API, and then by using these two API, we can the cell phone app can use to make a search function to search the data in our database. And I also work on the iOS app in this project, so so the users can have a mobile app and a clear user interface to use the service and find their vehicle very easily. Finally, I do all the software testing for this project.
This is a hardware system as shown in the video. The servo motor provides a rotation function for lidar sensor and camera. The lidar sensor was used to detect the distance from our system to an object. The distance will be returned as a result to help us determine if there is an existing vehicle on the parking spot or not. The Raspberry Pi camera was used to do the image recognition when we detect a vehicle on a parking space. One thing to mention is we replaced the original Raspberry Pi camera lens by another one which could provide a more accurate focus to suit for our application. Finally, we added a red dot laser to help us during the testing because we need to know the position that our lidar sensor and the camera was pointing to. To use our system in the outdoor environment for testing purpose, we chose to test our system in the SJSU North parking garage. The challenge was the system setup and the internet access. To solve those issues, we brought a camera standard to hold our system, and we used a power bank to power up our microcontroller. Also, we used the cellular data from a personal cell phone to provide internet access to our microcontroller. One thing to know that the distance and the rotation angles need to be measured for each desired position and calculated before the testing. When the software program was loaded into our microcontroller, the system was running. The servo motor drove the LiDAR sensor and the camera throughout 7 parking spaces where it was in the front of our system. For each position, it took approximately 8 seconds to process. The process included measure the distance to each parking position and compare with the expected value in our program so that the system would detect if there was an object on this position. If so, it would start doing the license plate recognition and uploading the result to the AWS. On the AWS, the entire 7 position where was in charge by our system can be updated within 1 minute.
So this is the output console generated by the Raspberry Pi. As you can see that this is our program can scan next positions. After scanning next positions, the system recognizes the car license plate. After scanning the license plate, the system generated JSON file that contains a confidence timestamp and the license plate. After generating a JSON file, the system sends the JSON file to the AWS. As you can see, here is the AWS confirmations. The JSON file contains license plate number and the locations of the camera and the timestamp. So rest of them is just like AWS confirmations.
This project we choose Amazon Web Service as our cloud computing platform and our database server. This is the AWS IoT console for our IoT device. Once we receive any message that published to the topic, car location, the AWS IoT will automatically split the message and push the message into the corresponding columns on our database. And here's our multiple rules that we set for the IoT device. And here is our database. So this is the database that stores the license plate information for the user, such as the last location and such as the location that the camera can be captured from the IoT device. And then here is the available space for each parking garage of each floor and rows of different parking garage. And then we have rights to name the functions for our IoT device. These lambda functions are used for API calls for the iOS app. So these two functions is written to read the database and then return the search results back to the iOS app. Here is the API gateway. So we will be using the HTTP GET method to make the API call to search the database, and then the response will be the data from our database. I demonstrate how our iOS app could work in the real life to help you find, search your own vehicle and any available parking space around you. First of all, you have to go to sign up a user account and then enter the password. The user account is for the security issues. Then finally hit sign up. Okay, like in the next couple seconds, we were able to receive a confirmation code. Just enter the confirmation code and then hit confirm. Your account will be active. So let's go to the AWS Cognito. So AWS Cognito will be our user login service provider. So all of the user information will be saved in AWS Cognito. Okay, so this is the username we just registered. The status is unconfirmed since we haven't entered the confirmation code yet. And then we can click into it and then see the email haven't been verified and the phone number haven't been verified, but the information we type in is already uploaded to the AWS Cognito. Okay, let's go back to the app. We sign into a testing account. After you sign in, hit search. We can search any available space at a particular location that around you. For example, if we are at SJSU North Garage right now, we can search, see if there's any space around us. Oh, okay, seems there's nothing around us. Okay, then let's go to South Garage. Okay, South Garage has 6 available space. If we forget where we parked our vehicles, we can just enter our license plate number. Okay, so this is my car's license plate number, and then let's see where's my car parking. So the latest one is 10:15 afternoon. I parked in SJSU South 43 Row H. After you finish, you can simply sign out.
Our project provides solutions for general parking in Cloud City. The purpose of our project is to improve the existing parking solutions by minimizing the number of equipment used in parking garages. Our system can generate a real-time image data from multiple sensors and cameras. After calculating the result from sensors, the system can send all the information to AWS data server. After receiving the data from S-Reply, AWS data server can forward all of the data to user applications. The system has already been tested in a real outdoor parking area. According to the testing results, the image was successfully converted into a JSON file that can be sent to the AWS server, and our user applications can get the correct information from our AWS server. For our future work, our team discovered that weather conditions would be a problem to our system. Therefore, we would have to make a waterproof cover to prevent our device from water dropping. Last but not least, our user application is only available for the iOS users. In the future, our team will need to develop an application serving on the Android platform.
你这后面